Hey there. So, in this video, we'll be talking about statistical measures or the realm of statistics. Um, okay, so let's get started. So, we're going to talk about per capita. By definition, it means the average per person. So, it could be any average of anything per person. So, you only need two numbers. You need some sort of value and the population count. The net worth, its definition, means it equals the total asset of wealth minus the total liabilities or debt. So we had those definitions. So let's move on to some problems. Example 1, per capita. Many business, health, and economic statistics are expressed as per capita figures. In March 2008, the national wealth of Canada was, this looks like, is this billions? 5,570,200,000. I think it's billion or trillion. And the national debt was 23. Same thing, 000,000. That's a pretty big number. And the population of Canada was, looks here, 33,223,840. That's a big number. So the question asks you, what is Canada's wealth capita? Okay, let me get my pen tool here. So it's asking for the wealth, capita wealth. Well, let's find the capita. So it's capita wealth. So what is our wealth? Well, it says here can national wealth. Wealth is this number here. This is quite an enormous number. I think it may be a mistake, but or maybe not. Let's take a look. So the wealth is here 5,702,123,123, right? Divided by the population in Canada, which is 33,223,840. And that is about it. That's all you need to do. We have a value of, well, this number is hard to say. I might just write it down. 171,623,623.75. Okay, now it's asking for per capita debt. Okay, same thing, capita debt. So we look for capita debt. Here is national debt right here. Same equation that goes on top, which is 2300,000. That is, oh, it's a number, yeah. And then another more O's. There we go. 23, 123, 123, 123. That looks about right. And then the population again. Is this per person? 223,840. And we should get, and this is, you should say here, per person or per capita, if you want to say. And this one here should be about 692.27 per person. This is the population. So this is per person or per capita. You can say that. What is Canada's capita net worth? Okay, the word net means you're always subtracting something when you hear the word net. So capita net worth, and that will be these two numbers here subtracted. So the income and then the debts. So it will be 5,702,123,123 minus, this is 23,123,123,123. Wow, that's quite a big number. and divided by the population of in Canada, which is 33223,840. And I had no space there, so I'm going to write below it, which gives me a number of, let me just scroll up here so it's easier to see, 170,931.48. And that will be, again, per person or per capita. So there we go. Everybody's, that's a person's net worth. Okay, we're talking about, this is sort of important here, percent change. So you want to know how it's changing from the old value to the new value. This is the formula here. This is the formula we're going to be using. And yeah, the best way to figure this out is to actually do some problems. Here, example 2, percent change. So the table shows the company profits for each year for 5 years as reported. So here we have our profits. This is last year. This has a negative profits. Calculate the percent change in profit from 2005 to 2006. Okay, so I'm gonna write here percent change equals. Now what is this? So here's the new and this is the old. I'm gonna say new and this is the old. Because this is the old, it goes from this to this. So 2006, the new here for 2006, and I should use maybe a big bracket there, is 364123. That's the new minus the old. The old is from 2005. It's 18623. That's it there. And it's all divided by the old, which is 18623, and an end bracket. And you want this in percentage, so you times it by 100%. And then you get the value. We have here 95.7, 5.7%. And there we go. Next problem says to calculate the percent change from 2008 to 2009. Okay, that doesn't seem, this seems like the same problem. So again, percent change, that's going to be this will be the new, and that is the old new. 2009 is negative 22000 minus 2008 is 212000. This whole thing divided by the old, which is 21200, times it by 100%. And let's see what we get. Yep, that looks about right. We get negative, because it's negative, it can end up being negative 110.38%. So this is negative actually means a decrease. So you're actually having a decrease of 110.38%. Okay, next problem. The company's the company's financial report states there was a 200% increase in profits from here to here, from 2006 to. Do you agree with this statement? Okay, so it says from 2006. Let's do the percent change. Let's do it manually for ourselves so we can see for ourselves whether or not it was a 200% increase. So this is the old, that there's a new 2000. So percent change equals, what's 2007? 2007 is 728000. 728000 minus 2006. 2006 is 364000. 364,000 divided by the old, which is 364,000 times 100%, and we get pretty much, actually, if you think about it, this is actually doubled. So this will be the exact same number. So it's actually 100% here. If you drop it in the calculator. So basically, it's a 100% increase because it's positive. Okay. No, what I mean was that it was only a 100% increase. So therefore, um, you disagree. Disagree. It was not a 200% increase. It was not, because it was only 100%. Okay, for the next lesson, percentile. Now we're getting to some interesting stuff. This can be a little bit tricky, but once you have experience, then you sort of get the hang of it. A number between 1 to 99 indicates the percent of a population with a score less than or equal to a specific value. So when we talk about percentiles, we're talking about values between 0 to 100. When we talk about percentage, we're always talking about values between 0 to 100. So same thing with percentile. So what we have here is percentile rank. So sometimes you want to know where are you in terms of your score. Like, are you the first place, your second place, your third place? That's what this formula does. Or are you on the 65? Are you in the top percentile or in the bottom percentile? So that's what this formula is. Here's a short form of the formula. This is just the long form, so this is the short form. L represents I didn't write it. The numbers below the scores less than the score that you're looking at. So you're looking at a particular score because you want to know where you rank. And here 0.5, the E is scores equal to it. So it's the frequency, how many times that exact same score keeps popping up. And here is the total number of scores that you're looking at. Now here, this bottom part, it's related to this formula here, except it gives you the actual rank number in terms of first place, second place, third place, so on and so forth. But you'll see that in a second, how we apply it. And the best way to explain this is through problems. That's the way I learned it. The table here gives a score on a high school marketing competition ranked from lowest to highest. Okay, and just so you know, this means is this here is from the lowest. Actually, I'm gonna make an addition to this note here because I'm not satisfied of this explanation. Here it says determine the percentile rank for each score. So we're gonna figure out the percentile rank. We're just gonna drop this into our formula here. So I'm gonna say percent rank. Use that for that. And let's look at 14. Okay, so the ranking is like this. Here's first place, they're the best. Here's last place, and here's 14. So the formula, as you may remember, is P equals L plus, it's plus, not minus, 0.5 E, the numbers of that are equal, and I believe it's divided by N, the total amount. And just so you know, N here is 12. I'm gonna write down N equals 12. Because 12, there's 12 entries. And here's the ranks, here 12. So percentile rank, drop it into our formula. So how many, okay, we have a rank here which is 14. Or not the percent, this is the determined percentile rank of each score. So this is score, this is a score of 14. 14 is right over here. How many are below? So this is above, and this here is below because it's ranking from 12. So 1, 2, 3, 4, 5, 6, 7. So there's 7 below. So you write down 7 here. And then plus, and then I'm going to put down in brackets 0.5. And it's asking you for the frequency in a sense. Like E means equal, but it also means frequency. So we have a 14 here. Do we see any other 14s? There's only one 14 here. So we're just going to put down here 1 because we only see just one of them. N is 12 because there's 12 entries. And here we should get our value, which is 63, or essentially it's 62.5. That is our percentile rank. I'm just going to round it up to 63. Make things a lot simpler. Okay, now let's do the exact same formula for this one here. So percentile rank. Okay, so our formula. How many, so we have here 11. 11 is right. Oh, there's actually three of them. Here, how many are below? So this is above because it's going from one. This is the first place and this is last place. So there's three. There's three below. Minus 0.5. And then how many 11s are there? There's one, two, three. There's three. There's three of them in total here. So write on 3 divided by 12 because there's 12 entries altogether. And we should get, oh, I forgot to multiply this by 100%. You have to multiply this by 100% to get the percent-wise. So let me just get an eraser. Let's erase that. Get my pencil. Times it by 100%. And we should get a value of, our value should be 37.5, 37.5%. And then we'll just round up to 38. Because every number likes to be even, except for this number here. Okay, so a score of 11 is essentially the 38th percentile, whereas a score of 14, you're essentially the 63rd percentile, the 63 percentile. Sorry. So what was that? That was a 14. So 14. So you're about 63. And I guess the better your score is, the higher the percentile will be. So that's how you would know. Now this one here, this is a little bit tricky. This here relates to this previous over here, this part here, this stuff here. And there's some rules that you have to know. So if you multiply n and p together, and if it's a decimal number, you round it up, and that's the position of the score if you round it up. However, if n times p, if that's a decimal number, you still round it up, but you take that number and the number above it plus 1, and you add those two. So yeah, the number above, or I guess the rank above. The best way to do this is to do problems. So let us do that. So here, I'm just going to write down what the P is. So the P percentile is 75% in a sense. And that you can translate that to P being 0.75 because you want to work in decimals. Same thing here. This is 95%. But we like to work in decimals. We always like to work in decimals. So this will be 0.95. There we go. So we have here, the formula is, I'm gonna say number rank. It's n. Is it n times p or p times n? Does it matter? I like to be consistent. So it's n times p. So it's n times p, which is 12 multiplied by 0.75. And we should get a number of 9. 9 right here. So that is our number rank, which means, and it's a whole number too. It's a whole number. So it's going to be 9, and because it's a whole number, I'm going to say number, we need 10. The rank just above that. So we 9 and 10, right? What is 9? So I'm going to say at 9, the score is, what's the score at 9? Here's 9, the score is 11. And at 10, the score is 9. So at 9, oh wait, just a minute. Sorry, remember I said this 9 here represents 9 from the lowest. So the lowest mark here is, if you look at it, it's this one right here. This is the lowest mark. Actually, give me a second. I'm just gonna, here we go. So this is the lowest mark. And if you count 1, 2, 3, 4, 5, 6, 7, 8, 9. So the lowest of 9. So it's actually 16. So 16 and over here 10, that's 17. So at 9, the value is 16. I'll say 16 score. And at 10, this is the lowest. It's the 10th lowest. The score is, I believe, 17 score. Therefore, you get the mean of those two numbers, and that'll be your score. I'm going to say mean. Basically, we're just getting the mean of it, or just the average. So it'll be 16 plus 17 divided by 2, and that gives us a value of 16.5. So that is our score. And this is the 70, it's at, I'm going to say at the 75 percentile. That's because we were here was the 75th percentile. So we do the exact same for this one here. Let's do the rank number, which is n times p, which is 12 multiplied by p. In this case, is decimal numbers, which is 0.95. And we should get 9. And it's a whole number. So we're going to have to do the same thing. Oh, wait, there's a mistake in the notes. It is not 9. It is actually 11. Sorry about that. 11.4. And here's a decimal number. So this is a decimal number. So therefore, we just round it up to be 12. So that's it. It's just so that the rank is at 12. So at the 12th lowest, if you, here is the lowest. If you count here 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Basically the first number here. So basically 19. So from the 12th lowest at 12, it's going to be a score of 19. Okay, that was a bit tricky, but let's move on. Okay, here, weighted mean. So some of you are wondering how your tests are calculated or how your exams calculate. Well, we use weighted means by this. So it's a mean in which each component has a different weighting factor. It is calculated by multiplying each factor by its weight factor, then dividing it by the sum of factors. So in your textbooks, they give you this. Let's say on during the course, you have 60% on your course, but the course itself is worth 70%, and the exam is worth 30%. And let's say you get 50 on the exam. So you get 60 during the course and then 50 on the exam. And these numbers are set. They're typically set by the professor. And you add them up here. 70%, 70% over 30%, and that gives you 57%. Now, an easier way of doing this, and this is the way I do it, you don't have to do this is the way the textbook does it, but the way I do it is I use the students' coursework and the course weight factor. And the course weight factor is basically 70% divided by the total here. In this case, it's 70 plus 30. This is actually 100%, so that'll be 0.7. And same here, whatever your exam mark is, multiply by the exam weight factor. And the exam is 30% divided by the total, which is 100%. So I do that. I have here the same example. So 60%, the student got 60% on the course. and a 0.7% course factor. 0.7% is you got that by dividing the course here, the course 70% divided by 100, and this is the 100 part, 70 plus 30. Over here, the same thing. It's basically 50%. That's the student's mark during the exam, and 0.3 is the exam factor. And you get that one by dividing 30% divided the total, which is 100. Well, so 70 plus 30 is 100, and you get 57. So they're the same equation, except they go about it a little bit differently. And I think this might be a little bit easier to understand, I think. So, but anyways, doing problems is the best way to understand it. And let's read this one problem. A college instructor uses weighted means to calculate his students' marks. And you have Zin's and David's marks are shown along with the weighting here. So here's a weighting factor. Quizzes are worth 15%, assignments are worth 15%, tests are worth 25%, independent studies worth 10%, performance tax is worth 10%, and final exam is worth 10%, 25%. I did the calculation earlier, and I can tell you if you add them all up, if you add all these up here, it's basically going to give you 100%. In short, it gives you 100%. These are Zin's and David's grades, what they got. So he got 24 out of 30 here. And so for the first part, it says there who had a better overall mark. Well, the very first thing you have to do is convert all these grades here into percent grades, because this is just a number grade. You have to convert into a percent grade. So it's basically 24 divided by 30 times 100 in this sense here. So a table here is done for you. Maybe in the future you're gonna have to do the table yourself, but in sense, his quiz mark is basically 80%. So all this is in percentages. So it's 80%. So 24 divided by 30 gives you 100%. Again, you look up here, it's 24, and the quiz was out of 30, and you times it by 100, it gives you 80%. And you do this for all of these here. So I guess again, 72 is the mark, and it was out of 90. So 72 divided by 90 divided times 100, which you do right here. 72 divided by 90, and basically 80%. So all this, Zin's mark is all in percentages. David's mark is all in percentages here. So how do we calculate it? Well, what we're going to do here is we are going to, we're going to use the first formula. You don't have to. I'm using the first formula because that's what they use in the textbook. So Zin's mark and his mark, and I'm going to put these in brackets. So the first one is 80% times 15. That's 15%. That's how much oops, let me go back there. That is how much the quiz is worth. Plus, and let me just go up here so I can see it all. So the plus we have here 66.7 times the assignment is worth 15 plus 74.2, and the what was it? It was the test was out of 25% plus 71.7, and that was worth 10% plus 85. Oh, I'm running out of space. 80 point brackets was 85. My mistake. 85 times it was worth 10. And I'm gonna go over here. I shouldn't. I believe it's 80 times 25%. The exam is worth 25%. And this whole thing is divided by, let me see if I have enough space below here. Actually, I have enough space. It's divided by 100% because I calculated all of these here when you add them all together. So basically it's 100% when you add them all together. And you drop that in your calculator and you get 76.2%. So that's his final grade. Now let's do David's. I'm gonna do this one a little bit differently. So what I'm gonna do instead is I'm gonna use my other method. So here I'm gonna write down. Let me just take a look. Here we go. So here I'm gonna write down 60 because he got 60. If you look up here on David's mark, oops, can't see it. Here's 60, right? 60 times, and I'm just going to use the weighted mark. So it's basically 15 divided by 100, which is 0.15. So it makes things a little bit simpler. Like it makes the equation easier. And then you have bracket 76.7 times, again, 0.15 plus 79.2 times 25, so that's 0.25. I'm just looking at this and then dividing it by that. That's how I'll get the decimal numbers of this. Plus 80, that's 80%, multiplied by, well, that was 25%, and that should be 10, or 0.1, plus we have here 82 times 10, or 0.1, and the last number is oops, let me just go back, bracket 71.1 times 25, so that's 0.25. That's a bit squished, and if you drop that into your calculator, you should get 1.8. Is that right? 1.8? Nope, that's not right. You get 74.3%. And if you want to know what the increase is, you subtract those two numbers. So the percent increase, you could say percent increase is essentially, or percent decrease in this case, or how high is Zin's mark in comparison. So it would be 76.2 minus 74.3, which you can see it's only a 1.8% increase, or Vin has an advantage of 1.8% in a sense. Okay, so that could be quite tricky and challenging, but it is as it is. Okay, that's about it.